So this is an interesting question you've given me. It's comparing smokers to non-smokers in terms of variability. And the smokers have a sample size of 61, and the non-smokers have a sample size of 121. Now, the last time I wanted to keep these kind of categorized so that way they weren't as ambiguous. So we're going to call this NS. We're going to call this NN just for a moment. And the S value here is 8.58, and the S2 value, so I'm going to call this SS, and then this will be SN, equals 5.83. Now, again, you're doing a measure of variances, so we're going to look at this from both perspectives just like the last one. So the sigma squared of the smokers should equal the sigma squared of the non-smokers. And again, this is a perfect world scenario, so this is going to remain consistent regardless of what you do. Because the null hypothesis usually assumes that all things are 3, 2, 1, pause for effect, equal. And as for your alternative hypotheses, now this one is saying that the variability in non-smokers is lower than that of actual smokers. So that means that we could say the variability in smokers is greater than that of non-smokers, or we could say non-smokers are less than that of your smokers. And I think you had the same problem here. You were talking about how you were supposed to get a value of 2.165 with the p-value. So let's see what I get here. So in this case, it's going to be a right tail test, which means that I want a significantly larger number. So we're going to be looking at 8.58 squared all over 5.83 squared. And let's see what we get here. Let me just punch this into my handy dandy calculator. Again, don't need to worry about parentheses here as much. 8.58 squared divided by 5.83 squared. And I don't know what happened in your calculator, but I get the... No, wait, I take that back. I do get the 2.16. 2.16. And let's see here. On the other end, if I was to do a left tail test, so 5.83 squared all over 8.58 squared equals 5.83 squared over 8.58 squared, enter, is the inverse, which is 0.416. Interesting. Let's take a look at this. Let's do some critical thinking together. So, S1, N1, S2, N2. Well, if we were to critically analyze the crackers out of this, just for a moment, and don't get me wrong, teachers are allowed to make mistakes and students are allowed to make mistakes too, not a problem. But you're saying that the F test statistic value was supposed to equal 1.929. So if we reverse engineer this just for a moment, 1.929 equals, and what did I say that original value was? We said that original value was 8.58. So let's call this S. Let's call this S squared just for a moment because we want to solve for that. And the other one was 5.83 squared. I'm going to do some quick algebra here, and you're just going to see what I'm doing at the moment. If you don't know what I'm doing, you probably need to review some of your old algebra. 83 squared. Let's see, so 1.929 times 5.83 quantity squared gives you approximately S squared equals 65.5 0.564. Take the square root of that, and you get approximately 8.09. So the only thing that I can think of is maybe when the teacher was doing this, she might have made a quick mistake. And again, nothing wrong with mistakes. But that would definitely explain quite a bit, unless I'm completely reading this problem off. But it looks more like let's see. It looks more like a decimal error, especially right here. Instead of a 0, she put a 5, which would make sense in the long run, assuming that you're looking at the correct question. But all I can tell you is you're not losing your head. I got the same answers you did. I looked at the same question you did. So you're not going stir crazy. That's really all I can say, but definitely take this up to your instructor. And if you need to, you can show her the math that we did. You can show her the video that we did. And again, I may be going stir crazy, but I highly doubt it. So anyways, this is your explanation. Thank you very much, and I'll see you next time.